To use GlowScript for programming, we can just go to the website glowscript.org. GlowScript is a type of Python. It does not have all the features of Python, but certain things are easier. And this is what we will be using. So when you get to the site, you do see a place to sign in the upper right. You can create an account, or you can simply use a Google account, which is what I will do here. And you see a similar screen. What you can do is pause the video as you go and try things in the site. So it says you are signed in as who you are and your programs are here. So if you click on that, programs are here. I have a whole bunch of things. In your case, you could create a folder if you like. Give it a name. And that helps you organize things. Then you can create new program. Give it a name. I will call this exercise 2. And it brings you into a window where you can edit your program and type in code. This first line is filled in automatically. You need to leave that there so GlowScript knows what version you're using, because there are different versions. I like to use blank lines to help separate things for ease of reading. So I will assume you have not worked with computer programming or computer coding before, and go through the different pieces of code that are part of the exercise and explain how they work. In computer coding, an equal sign is not just a mathematical equal sign, it's making something happen. So with the first line of code, you're given the uppercase E and lower and uppercase do matter, equals. The left side of the equal is the name of something or a place in memory where we're putting something. And to the right of the equals is what we're putting there. So in this case, this is the speed of the Earth, which you can look up 2.978. And then to do scientific notation, do E for exponent, and this is 2.978 times 10 to the 4th power. The computer code does not know units. You can help keep things straight by always using SI units, but it also helps if you put a hashtag. Hashtag is the start of what's called a comment, which is for the reader's benefit. The computer ignores it when it's running the code and doing its calculations. So it's good to put in the units here, meters per second. So this creates a number, the speed of the Earth, set to equal to 2.978 times 10 to the 4, and a notation so we remember this is meters per second. Hit enter. It starts a new line. A nice thing about GlowScript is it automatically can deal with vector quantities. So the velocity of the Earth, you can call it whatever you want. I'll call it Vel, capital E, Earth. And that's a place in memory. And we're going to put something in that memory. And this is going to be a vector quantity. So to tell GlowScript we're creating a vector, type VEC for vector. And inside parentheses, we put the 3 components of the vector. So for instance, minus VE for X, 0 for Y, 0 for Z, Notate the units again, meters per second. This will create a vector whose x component is the negative of the speed, y component is 0, z component is 0. So this is a vector indicating the Earth, and we have set up the coordinates so that the Earth is moving in the negative x direction. Another way you could do this, if you prefer denoting a vector a different way, I'll write this in a comment so it will not actually execute. It's simply showing another way. Vel Earth equals, and then we'll type the magnitude of the vector, V capital E, and multiply it by, which is an asterisk, a vector, and we'll denote the unit vector pointing in the right direction, -1, 0, 0. Those are two different ways. They're equivalent. So now we have created a quantity for the speed of the Earth and the velocity of the Earth, and we've given both of those names so we can use them for later calculations. To show that you've done something, I just run the program now. Nothing happens. When you click Run Program, it shifts to a screen that shows you the output of the program, and output only happens if you do a print or some sort of graphics type statement. So to show that we've accomplished something, we can print. Inside the parentheses is the thing we want to print. If I put inside of quotations, I can say speed of Earth, and a comma, and then the number I want to print, VE, and then my units, meters per second. The stuff inside of parentheses will print as is. Something that's not in parentheses, such as VE, is indicating that there's a number or some other quantity located at VE, and it will print that. You can guess perhaps how we would print out the velocity of the Earth. Second. Print inside of parentheses, velocity is Earth. Separate by commas the very different things you want to print out, and inside of quotations again, I'll put the units. So now we have code that will have some output is printing some stuff, so it will show up on the screen. So if you run the program, it will look like that. So it's the speed of Earth, and then it prints out the number, and then prints out the units that I put inside of quotations. And for the vector, notice that it denotes a vector using the angle brackets, so to speak. Let me show you what happens if you have an error in the program. So supposing I do print and forget the parentheses. And then it pops up a window that says you've made a mistake, and look at it, and it tells you what line it's on, and it says unexpected token. It's hard to know sometimes what these things mean, but to fix this, you can't just exit out now. You have to go back to the editing window and say, I did something wrong on line 7. And in this case, I have to actually put whatever I am printing inside of the parentheses. Now I can X out that error window. I like to say you should save early and often when you're writing computer code. However, GlowScript will automatically save something up in the cloud and keep it up to date. At some point, if you want to show someone else your code, say your instructor, you can click on share or export this program. And the easiest way is if you go down to where it says you can publish a link to and all this stuff in blue. If you right click on that, you can copy the link address. So for instance, then if I open a new tab, paste that in and go there, it will take me to the same place. So if you send that link to someone, they will be able to see your program. Okay, back to editing. Another thing that is part of the exercise is you may have done some algebraic work to deduce the starting position of the Earth and starting position of the asteroid, given the quantities of their speeds, and assuming that the Earth is moving in the negative x and the asteroid is moving in negative y. So I'll assume you have done that and show you how to type that formula for the position of the Earth, which involves several calculations. I think it'll be best if we break things up a little. So I'm going to comment out these print statements for now, so we're not printing a lot of stuff. Basic setting up a computer code to do computations. Let me just say A equals 4, B equals 3, and simply run through how to do the basic calculations that you'll be needing for this exercise. So if you want to say A plus B, and this is in quotation marks, so we'll actually print A plus B equals, and to calculate A plus B, you, in this case, can just type A plus B, but now it's not in quotations, and it will do that calculation. And it prints out A plus B equals 7. So in fact, you can also, instead of doing that, you can say create another quantity C equals A plus B, and instead of typing A plus B in the print, you can just type C. It should again print out 4 plus 3, which is 7. Most of the math quantities match pretty well what you would write. So A minus B, 4 minus 3 should be 1. Multiplication we've already seen. That's the asterisk. 4 times 3 should be 12. I didn't change it here. So I have to set C equals A times B, and it'll print out C. The program is just going to run through line by line. So things will happen in order. What else can we do? A divided by B is a slash. So that should be 4 divided by 3. And it prints it out with a whole bunch of digits. What's left? Doing a power. A power is one that is a little tricky. You can't just do a superscript A, superscript B. In a lot of other situations, you could do a caret, but a caret in Python does something completely different. So in GlowScript, to do a power, we do a double asterisk. This will be A to the power of B. So 4 to the power of 3, 16, 64. One other thing we can do is do a square root. So if we want to do the square root, of A. Then we use what's called a function. Print is actually a function. What a function is you have something, the name of the function, in this case SQRT, which is the name of square root. Then inside the parentheses, you have something you're feeding the function. In this case, the number denoted by A. So this will find the square root of A, and A is 4, so this should give us 2. So those are the basic pieces of math that are part of this exercise. I'll put in a comment here to remind you that as part of the exercise, you will be creating a velocity of the asteroid and the velocity of the Earth, of the speed of the asteroid, and also a distance. So we have created a distance d, which will be the starting distance between the Earth and the asteroid. And you have created dA, which will be the speed of the asteroid. And that is part of the exercise, is you creating those. But if you have created those, then the code sample in the exercise shows you how to implement the equation that you will derive for the initial x coordinate of the Earth, given the initial distance, given the speeds of the two. And now, using the pieces, you can type it in the way it would look if you wrote it out, almost. So again, x, we'll use x for the original x coordinate of the Earth. And we're going to put something there. We're going to put something there that is calculated. And that is d, the original distance, divided by square root. The square root of what? Well, the square root of 1 plus, and then a quantity, the ratio of the speeds, VA over VE. That quantity gets squared, so double asterisks. We have to close the parentheses, and there we are. I try to run it now. It will not run because it has not filled in all of the code yet. So it helpfully says, oh, I don't know what D is. And that, again, is part of the code that you are filling in as part of the exercise. So you can complete the code to complete the exercise. The next video will discuss some other features that appear in exercise 3 and the pieces of code that are given to you to work with in exercise 3.